Okay, geometry students, this is the second section, measuring and constructing segments. All right, so we're going to learn how to use the ruler postulate. Basically, we're going to learn how to use a ruler, which hopefully you already know. We are going to copy segments and compare segments for whether or not they're equal length or congruent, and we're going to use the segment addition postulate. So starting off pretty basic here with these geometry lessons. All right, so the first step is to measure the length of a line segment. Once again, this symbol over the top here, just the line with no arrows on it, means line segment. All right, so once again, just to review, ST means the length from S to T, or the distance. ST with a line over it means segment. You're talking about, you're naming this line segment. And then ST with a line like this means you're naming the line. And then ST with array over top of it right there, means array with a starting endpoint S. So those mean different things. You need to know all those. All right, but we're measuring a line segment here. So I'm going to take out. It wants it in centimeters, so I'm going to use centimeters on my little ruler here. This is actually a compass. I like it. This moves a little too easy, but we're not going to use a compass a whole lot in here. But it's really a basic foundation of geometry that if we could do it remotely better, we would, because it is, I know you don't use it a lot in the real world, but it is kind of the way in which we used to construct geometrical shapes with accuracy. All right, and it's a good foundation for learning some of the basics of geometry. But anyways, to measure a segment, we're going to just put the starting point, the little hash of 0 right at the starting point, and we're going to go to the end point. So centimeters is really intuitive. The metric system is very intuitive. You have 3, and then you have millimeters here. So you have 1, 2, 3, 4, 5, 6. I'm going to say 7. So I'm going to say 3.7 centimeters. Now, you might be different here. If you printed this off yourself, you might find that to be a little bit different based on your printer and the image size. But I'm measuring mine to be about 3.7 centimeters. This 0.7 means 7 millimeters extra above 3. All right. All right, the next example, we're plotting 4 points in the coordinate plane and to determine whether they're congruent. I did include a graph here, which maybe I shouldn't have, but I didn't want to be handwriting and make it not clear. But, J is the point -3, 4, so hopefully you guys know how to go back 1, 2, 3, and up 1, 2, 3, 4 to plot a point, right? This is the x-axis, the y-axis, and, this is the x-coordinate here, and then the y-coordinate. So you have to remember how to plot points, and hopefully you know how to do that. But once you plot these 2 points, you get line JK here, and you get line LM here. All right. Now it says to determine whether these are congruent. Congruent means equal length. All right. So that means equal length. We're going to use that word all year long to mean equal, basically. All right. The same. So if we could use the distance formula, which we'll use later throughout the year. But for now, let's just use the fact that we can use the ruler postulate, which means that the ruler postulate is you either count, right, or you take the bigger number minus the smaller number and make it positive, or you just subtract the coordinates and make it positive. All right. So in this case, since this line's along the x-axis, we're going to use the x-coordinates. We're going to use -3 and 2. Basically, if you subtract those, -3 minus 2, you get -5, and if you just make it positive, you get 5. That's the ruler postulate. You subtract the coordinates and always make it positive because we're talking about a positive distance. But it's a little more sense to go from the bigger one to the smaller one. If you do 2 minus -3, that gives you 5 right away. All right, so that's the ruler postulate. You just subtract the coordinates in that direction, and it will give you the length, as long as you make it positive. So in the vertical direction then, that is, by the way, I'll label this JK. So label it JK means the distance from J to K is 5. All right, now let's do the distance from L to M. Okay. Now the distance from L to M, I'm going to use the y coordinate. So I'm going to do 3 minus -2, which also gives me 5. All right. So once again, subtract the coordinates, make it positive. In this case, I have to do the y coordinates because we are in the vertical direction. That is, our x coordinates are the same. It's our y coordinates that are different. All right. Now obviously you can just count 1, 2, 3, 4, 5 and see that it's 5 units long as well. But if they're bigger picture, bigger coordinates, that the ruler postulate's the way to go. Now, since these are equal length, now we can say that JK, line segment JK, is congruent to line segment LM. That is the symbol for congruence. All right, and that's what we're going to use all year long. So if you want, you can use little 3 dots. This means therefore in math, but this is good for me. If you do this on a homework problem on a quiz or a test, you're going to get full credit. I can clearly see you are saying the distance from J to K is 5, then you're saying the distance from L to M is 5, and then you're saying that these 2 lines are congruent. All right, math is about clear communication, and the work that you show and how you label it and then how you box your answer, those are all things that we're grading. We are going to give you partial credit. You know, if you make a mistake somewhere, let's say the only mistake you made was you had a plus sign here, and therefore your answer turned out to be 1 here. All right, 3 minus 2 is 1. All right, and then you said they're not congruent. All right, if I see that and you show me that, I'm going to give you a lot of partial credit. All right, as much as I can possibly give you, because you only made one small mistake in a problem that's worth, you know, maybe 3 points. All right, on a quiz or a test. All right, let's try another example here. Example 2, I didn't really label this. Actually, let's call this example 3. All right. Example 3 says find the distance from D to F. The distance from D to F, now we're using the segment addition postulate. All right, the segment addition postulate. Okay, the segment addition postulate just says that the length from D to E plus the length from E to F equals the length from D to F. That is the segment addition postulate. It's very simple. Postulates, by the way, are simple. So when we're talking about postulates, they're accepted statements of fact. This guy who wrote this stuff 2,000 years ago, Euclid and Euclid's Elements, you know, had to have a starting place. And the starting place was, what can we all accept as true? Let's start with the basic of the basic. All right, the fact that, hey, if I have this little piece here, and I add it with this little piece, I get the whole thing from D to F. That is the segment addition postulate, and it's very simple. All right, and here it is in I guess our math language, all right, or symbols. All right, so it wants the distance from D to F, so I'm just going to go ahead and substitute in fact, if you just write this right here, right, and then you say, okay, well, DE is 23, so we're substituting now, and EF is 35. Then I get my final answer, which is 58. All right, so now I can say the distance from D to F, which they asked for, is 58. All right, and then same thing here with GH. The part B wants us to find this little distance here, GH, so I'm going to label that X, I guess. And then I'm going to go ahead and fill out the segment addition postulate. So we know that the distance from F to G plus the distance from G to H is equal to the distance from F to H. All right. Now, that's the segment addition postulate. In fact, I'll write that segment addition postulate because later when we do proofs, we are going to justify each step as we go. So might as well start now. All right, now we're going to substitute. So FG is 21. GH is what I called X. And FH is the entire distance, which is 36. Okay, that is just substitution. And then I'm going to subtract 21 from both sides, and that gives me X equals, it looks like 15. And that's not X. I'm going to go back and call that the distance from G to H equals 15, because that's what they asked for, not what I called X. But if you label that, I won't mark that wrong. I see, hey, you're labeling GH X, and you're saying the answer is 15. Okay, last example then. We have some cities on a map. We have Lubbock, Tulsa, and St. Louis. I'll call this L, T, and S, I guess, for our coordinates here. And I'm going to use the segment addition postulate to say LT plus TS equals LS, right? Segment addition postulate. All right, so that's the segment addition postulate. And now it gives us the distance from Lubbock to Tulsa is 377. It gives us the distance from Lubbock to St. Louis is 738. So we just need to find this distance I'll call X, which is the distance from Tulsa to St. Louis. All right, so let's go ahead and substitute. LT is 377 miles. Distance from Tulsa to St. Louis I called X. And the distance from Lubbock to St. Louis is 738. So now we can just subtract from both sides. And that gives us our distance from Tulsa to St. Louis, which is 361 miles. Okay, and That's it. We can just label that, and if you want to write, hey, this is the distance from Tulsa, Oklahoma to St. Louis, Missouri, that's clear as well. But this is good enough. Justified each step here, segment addition postulate. Here we use substitution, and then we did subtraction, or subtraction property of equality we're going to learn. All right, so that's all I have for you. I hope this helps, and I hope the homework goes well, and I hope you guys have a great day.